Hello DEF CON Red Team Village, my name is Darren Roberts and you are here for 2-hour training on Atomic Red Team Basics and Beyond. Let's go ahead and get started. So like I said, this is Atomic Red Team and my name is Darren Roberts. Let's go through the slides here. My wife is also joining me, Carrie Roberts. She is going to be on Discord as well. Any questions that you have, she is more than capable of answering. So please don't hesitate in asking your questions. If you have any, she knows everything there is to know about this. So I'm a security analyst with Black Hills Information Security. Carrie is a red teamer that has turned blue, and she's also one of the maintainers of Atomic Red Team, so she knows everything there is to know about Atomic Red Team. So go ahead and ask your questions there in the Discord channel if you have them. So again, this is going to be a 2-hour class. We're going to go over a brief overview of MITRE ATT&CK. And then we're going to go into Atomic Red Team, and we'll have a little intro and background, and then we're going to have some labs for Atomic Red Team. We're also going to talk about the attack navigator and how that can work with Atomic Red Team. And then after the class is over, there's going to be some lab time. So this class is, originally it was designed for a 4-hour class. So we had labs built in and the lab time built in, but we've condensed it down to 2 hours. And so there is labs with this. I'm just going to go over the labs. If you would like to do them on your own, go ahead and ask. Again, you can ask Carrie, send her a direct message in the Discord channel, and she will set you up with the lab environment for you to work on. So I think that's all for the agenda. So we also have access to the slides and the labs, and we will get you that information. You should have it. Look in the Discord channel for that. We'll make sure that it's there, and you can go through and look at the labs and all the information that's there also. Okay, so MITRE ATT&CK. Most people know about MITRE ATT&CK. It's a great way that the MITRE Corporation has set up that looks at attacks and classifies them and categorizes them so that me as a red teamer, I can look through that and I can see the techniques that people are using. For blue teamers, it's great, again, to see what techniques people are using in the real world, and so that we can look at that and either how to defend ourselves from it, or maybe even look to see how we can use that information to help create attacks to better defend our environments. So the MITRE ATT&CK stands for the Adversarial Tactics, Techniques, and Common Knowledge. So it was officially released in May of 2015. So it's been around quite a while, and it gets updated fairly regularly. In fact, it has just barely last month. The beta version that they had for a while is now live with the sub-techniques. So that is now officially part of the MITRE ATT&CK, and we'll get into that a little bit. So this is constantly evolving. It's changing all the time, and it's again, it's real world, what people have seen in real world situations and attacks, and it's a great tool that we have to help us. So when we look at the MITRE ATT&CK, most of the people think of the matrices. So these matrices, again, it's just an easy way to look at this information. There's the pre-attack matrix. That's kind of what happens before the attack happens. It's stuff that you don't really see on your network. And then the enterprise matrix, which again, that when you think of MITRE ATT&CK, that's basically what you think of. is the enterprise version, even though there are these others. And then we have the mobile and the industrial control systems matrix as well. We're not going to go into their pre-attack, the mobile, or the ICS matrices. We're just going to stick with the enterprise because that's what MITRE, that's what Atomic Red Team focuses on, is the enterprise matrix. So if we take a look at this matrix, we see that again, it's just broken down into almost, I mean, it's like a spreadsheet, but if you look across the top row, these are the attacks that people, that these attacks have been classified into. So initial access, execution, persistence, and so on. So those are the broad categories. And if we go down into the columns, if I can get there, maybe I should use the arrows. If we go down into the columns, we can see the techniques that are under each of these tactics. So if we look at the credential access tactic, we can see that there's a bunch of different techniques to get credentials. The top one is probably my favorite, the brute force. Again, you can see that this is these little things on the side. These are now the subcategories, sub-techniques, sorry, and these are the sub-techniques. And these used to be their own technique, but they've categorized them now into main techniques, and of course we've got the sub-techniques. So each of these sub-techniques here is just a different way to brute force. So we can guess passwords, we can crack the passwords, or my favorite is we can spray passwords, and then there's credential stuffing. So each one of these has a different method to it, I guess. So it's, in my opinion, it's great that MITRE has broken these out. Password guessing is just that. You can guess what the passwords are. Password cracking is where you get the hash and you try to crack it. You try and get the clear text password from that. Password spraying, you have a list of users. You guess one password over that list of users. That's my favorite. It's a great way to attackers get in. At least that's a great way for red teamers to get in. Happens fairly common in at my work, where we guess passwords with password spraying. Then credential stuffing, where we have a list of users with passwords that have been leaked in major leaks that have been disclosed publicly. We find out which users a company has. We guess the same passwords because everybody knows that reusing passwords is a great thing. Not. But do people use reusers of passwords? So that's what credential stuffing is. So you can see that while each one of these sub-techniques is a form of brute forcing, they're very different in their methods of attack. So that's, in my opinion, that's a great thing that they've done to get these sub-techniques out of the main technique that's there. And not every technique has a sub-technique, but quite a few of them do, as you'll see when you get into this a little bit more. So again, we can look through the details of these. We can look at what the definition of password spraying is, and we can see here, this is taken right from the MITRE ATT&CK site, that there's 4 sub-techniques that we talked about. Of importance here is this box outlined in red. This is the ID for this password spraying brute force sub-technique. So the technique is right here, T1110. So this T number is very important when you get into working with Atomic Red Team. And the sub-technique is given a sub-technique number of 0.003. So the ID number for this is T1110.003. So it's hard to memorize all of those T numbers, but just make sure that you realize that that if you go to the MITRE ATT&CK site, you can find the T numbers there. You can, and that's how you're going to use what you're going to use when you identify these techniques in Atomic Red Team. So that's important to see. Also on the MITRE ATT&CK site, we have procedure examples. So again, these are things that people have seen in real world. So this isn't just something that somebody thought was an attack that might work. These are actually attacks that have worked and have been used. And you can read through some of these procedures and get more information about them if you want. Again, these are just ways, things that people have seen and why that technique or sub-technique is valid there. There's also mitigations and detection. So what can we do to mitigate this problem? Again, with brute forcing passwords, multi-factor authentication is a great mitigation. You're probably not going to eliminate all of those risks there, but with two-factor authentication, it's seriously going to reduce the impact that you can have with that. So there's mitigations and then the detection. So how can we detect one of these attacks? There gives, again, great information on the MITRE site that we can use to help us. So there's also other views that we can use to see these T numbers. So this is a great view here. We can see the name, the T number, and the description. So we don't get a lot of the other information that was there, like the mitigations, the detections, and all that kind of stuff. But we can see the main information. We get the T number, the name of it, and the description, so we can kind of know what it's talking about. So that's a great page to look at when you're looking through things as well. So this brings us now to Atomic Red Team. So what is Atomic Red Team? Atomic Red Team is a repository of small scripts that mimic what attackers do in real life. And so you can, in your own environment, you can use Atomic Red Team, and you can run these simulated attacks on your own network, and you can see if you can detect it, or see if you can block it, or whatever it is. Like with things like that, you can do that with yourself now with Atomic Red Team. So it's a great tool that we have that has been created. If we think of the TTPs that are so common, the tactics, techniques, and procedures, the tactics and techniques we just talked about with MITRE ATT&CK. So MITRE ATT&CK does a great job with enumerating the tactics and the techniques. They go through and they say these are the tactics that people use, these are the techniques that they use, but they don't enumerate the procedures that people use for these tactics and techniques. And that's really where Atomic Red Team comes into play. So Atomic Red Team has these procedures, and they've scripted these procedures so that we can mimic what attackers do, again, on our own network. So what is the Atomic Red Team project? It's originally started by Red Canary. It is free and open source, so anybody can use it and also contribute to it. So there's over 100 contributors from everywhere that have participated in this. And if you are so interested, you can join the dedicated Slack workspace for the collaboration with Atomic Red Team. And right now I just checked, there's over 1,900 members to this Slack workspace. Sorry, I had a cough there. Okay. So if we look at the Atomic Red Team repo, there's a lot of information there. The main thing that we are going to look at for us is this atomics folder. We're also going to get into the use of the execution frameworks here in a little bit. But let's first take a look at the atomics folder so that we can get some more information. We can understand kind of what is in this Atomic Red Team. So if we open up the atomics folder, we can see that we have an indexes folder, and then we have a bunch of these T-numbered folders. And you can, hopefully, you can imagine and see that these T numbers are going to exactly go, what's the word I'm looking for? They are going to be the same thing that is in the MITRE ATT&CK framework. So what we saw in the MITRE ATT&CK framework with their T numbers, these T numbers are going to be the same. So unfortunately, we don't get to just look at this and say, okay, T1003 is, whatever. We have to kind of go back and reference what that is somewhere to find out what that is. Unless you have a great memory and know what all those T numbers are, you're going to have some kind of a reference point to go back. But again, this is going straight from MITRE ATT&CK, so that it is very well documented. If we open up one of these technique folders, we can see that there are, didn't want to do that. We can see that there's, again, a folder. Sometimes there's the source folder, but the main things that I want to talk about here are the markdown folder and the markdown file and the YAML file. So every technique folder, the T-numbered folder, is going to have at least these two files, at least one MD file and a YAML file. So this is kind of what tells, kind of says what's going on with the technique here. So if we open up the YAML file, we can see some things here. We can read what it is and we can kind of get an idea. YAML is a great way to tell machines what to do. It's a machine language. It's not as easy for humans to read. We can look through and we can kind of get an idea of what it is, but it's not as easy to read as the markdown file. So if we go to the markdown file, again, we can read this much easier. So we can see that the atomic test number 1, system network configuration discovery on Windows, identify network configuration. The platform is Windows and the attack commands. So all this information was here. System network configuration discovery, identify network configuration information, platform is Windows, and the commands. But it's so much easier to read this way. So if you want to read the YAML file, you can when you're looking through this information. But again, the markdown is much easier for us to read. Interestingly enough, when and if you create your own atomic test, all you do is create the YAML file, and the markdown file gets updated and created automatically. So that's, in my opinion, that's really cool. But anyway, that's a whole nother topic. Okay, so now that we kind of have an idea of what Atomic Red Team is, and we've looked through the markdown file, the YAML file, let's go ahead and we're going to run an atomic test, except we are going to run it manually, meaning without the framework involved. So let's go ahead and I am going to open up the labs. Just a minute. I just realized that I didn't have this opened before. Sorry. Okay, so we're going to go ahead and walk through this first lab. So what we want to do is we want to basically it's going to look through the atomic red team folder. So we're going to do a search for atomic red team GitHub. We'll go ahead and click on this, and again, here's the nope, I want to make this bigger. Okay, hopefully everybody can see this now. So we're going to go ahead and look at the atomics folder. We can see all of these T-numbered folders. Again, we talked a little bit about that already. If we go into this T1016, we can see that there is, this is the same thing that we just looked at, number one. So we're going to go ahead and we are going to run this atomic test number one. So what this says is these commands are going to run with the command prompt. So I'm going to go ahead and open up the command prompt, and actually I already have it open here. And I think that font is big enough. What I'm going to do is I'm just going to copy these commands and I'm going to paste them into my my command prompt. We can see that all these things ran. We can go through and we can say, yep, we were able to get the IP configuration. This is great. If I'm an attacker, this is one of the things that I want to do. I mean, this gives me a lot of information about the internet, what I'm looking at here. And then we've got, again, all of this great information that an attacker is going to want to know. So if you were going to run this for yourself, again, we'll probably talk about this later. What are you going to do with this? Well, you're going to say, okay, they were successful in running this, but is it bad that they run this? Is it bad that a regular user can run this? Maybe. I don't know how many regular users are going to need to run netconfig or any of these other commands for that matter. But it's not necessarily bad that they can. Maybe you don't want them to run it. And so you would put a block on that command. And then you could try it again. Maybe instead of blocking it, maybe you would just put an alert. So if somebody does run this command, you would say, okay, alert us if they try and run this, and we can look into it and see why they're running it. If it's an attacker, we can stop them. If it's a regular person, we can find out why they would want it. Maybe they're having computer problems or something. So there's all kinds of information that we can get from this. I'm just running this command. Isn't very useful unless we do something with it. But you can see that we can run these commands manually. Again, the commands are here. Copy and paste them into the command prompt, and we are done. So it isn't very hard to run some of these tests. Just run them manually. But other times we run into some problems. So some of these tests might be some of the platforms that, well, this specific test here is for Mac or Linux, so that might be a little bit. I mean, we don't want to run that on a Windows machine. It wouldn't work. Wouldn't give us any valuable information. Some of these tests have input arguments. So if we have an input argument, what do you do with that? Are you going to take the variable and get the file and copy it over before you copy and paste it into your command prompt? So all of these, there's a lot of problems with just running these tests manually. Also, in it we have cleanup commands. So after you get done creating and running these tests, what are you going to do with the information? Well, sometimes you don't want to leave that information on the system, so you've got to clean it up somehow. Some of these atomic tests have dependencies, so you've got to get a certain file or a certain program or script or something that is going to run. So you've got to get the dependencies. Again, you can get those manually, but the framework really helps out. So this is where the execution framework really gives us a lot of information. So with the execution framework, the execution framework is going to run these tests as specified in the Atomic Red Team repo. It's easy to put in our custom input arguments or any input arguments. And another thing that is beautiful with this is we can actually script these tests. So if you were trying to secure your network, maybe you want to run these tests once a week. Maybe you want to do it every day. Maybe you want to do it once a month. But we can script all of these tests if we want to run at a certain time or run only some of them sometimes. So it's much easier than looking through the Atomic Red Team repo, copying and pasting the files in. So hopefully you can see that the execution framework is going to be a beneficial thing for us. So the Atomic Red Team execution frameworks, the main Atomic Red Team framework that we have is written for PowerShell. So it is the one that's been the most developed. It's a great thing with it. It works cross-platform. You can run it on Linux and Windows and Mac OS. So Linux and Mac OS, you can run it with the PowerShell core. Windows has PowerShell natively with it, so you can run it with that. There is a Python execution framework. It's not as developed as the PowerShell framework is, but again, it runs on Linux and Mac OS. So if you don't have PowerShell core, if that's not an option, you can run the Python version. The Ruby version is also there. It's outdated. It's just a proof of concept, basically. It hasn't been updated for quite a while. But if you like Ruby, I guess you could use that one as well. So the PowerShell execution framework is Invoke Atomic Red Team. So there's a great wiki that's there. Talks about how to use it, how to import it, all of the information there. I do understand that sometimes reading those things isn't the funnest thing to do. So we're going to go through and talk about how to import it and how to use it. So the first thing that we're going to do is list the atomic tests. So with the atomic tests, we actually, before we get there, let's install Atomic Red Team. I guess that's kind of an important step before we start doing anything else. So where's my mouse? Okay, so let's go ahead and install this. I'm going to go back to the Atomic Red Team GitHub page. Maybe my mouse is not cooperating. Oh no. My computer is being not fun right now. I hope it doesn't die. Okay, so let's look at the Atomic Red Team repo, and we're going to click on the execution frameworks. So this is that folder that I said that we might get to. This has kind of the same information that we just talked about, but the invoke Atomic Red Team execution framework is actually in a different repo. So we're going to get there with this link here. And I probably should have opened that up in a new window, but that's all right. Okay, so let's look at the installation and usage instructions. And these instructions, these are spelled out in the labs. So if I'm going too fast or you're confused or something, you can basically follow this, do the same thing on the labs. So I hope you don't feel like I'm going too fast or anything. What I'm showing you is it is the labs. So I'm going to go ahead now, and once I'm here at the home page for this, my computer is something's going on with it. Okay, hopefully it settles down. So I'm going to go to the wiki, and I'm going to click on the installation. So from this page, I can see that we have some instructions here to install the Atomic Red Team framework. What we want to do is we are going to do this in PowerShell. So I've got PowerShell open, and I am going to copy these two lines, and I'm going to paste them in PowerShell. Okay, so I have got this web request. I have basically got that information. I'm going to install this Atomic Red Team now, and maybe it's going to work. There we go. Okay. So let's see what happens with this. We're going to install Atomic Red Team. Boy, something is going on with my computer. It shouldn't take this long. Okay. We need to hit enter for this. It is installing. Installation of Atomic Red Team failed. So we get this red error here. So why do we get this error? Well, it says that this file cannot be loaded because running scripts is disabled on this system. So I could have explained what to do before we got here. I hope you'll appreciate the labs. So I do try and show the common errors that are going to happen. We want to run scripts. By default, PowerShell doesn't want you to run scripts. So you've actually got to specifically tell it that you are going to run scripts when you start it. Or you can set the execution policy. So we're going to go ahead and set the execution policy. Set execution policy, and we're going to do bypass And the scope needs to be the current user. Okay, so yes, we want to do that. Okay, so now we've just changed the execution policy. We've said, okay, we're going to allow scripts to run. So now I want to run or install Atomic Red Team again. I've kind of installed it already, so I'm going to just do force to make it go again this time. So let's see what happens this time when we run this. Okay, so this time we didn't get any errors. We got installation of invoke atomic red team is complete. You can now use this function. Now, one thing that is interesting to me is the last time I did this class, I got an error that said that Windows Defender didn't like it. And I had to basically go through and do some things with Windows Defender. I guess that's been fixed because we didn't get that error this time. It'll come up later. Don't worry. We'll get to do all that. But anyway, that's kind of, this is being changed all the time. So maybe somebody found out why and made it so that it wouldn't get flagged. I'm not exactly sure. So anyway, we didn't have that error. One thing that we can do, and that probably should be done, I guess, let's see. So let's go through. I want to look at, there's Atomic Red Team. Invoke Atomic Red Team. But that's, so this is the files here for Invoke Atomic Red Team. But this isn't where the repository is for all of the attacks. So that is in C user. So this is just where it got installed. C users art, maybe. Well, that isn't working like I was hoping. Give me just a minute. Okay, so this should have created, and I'm looking at trying to figure out why, but this should have created the files for we should have our atomics folder here, but I can't figure out why we don't have that. Oh, that's why. Okay, so we've just installed Atomic Red Team. Sorry about that. So we need to actually get the Atomics folder now. So instead of just installing Atomic Red Team, we want to get Atomics. And again, we need to force that. So sorry about that. So now we are downloading all of this information. And this is when we're actually probably going to see some alerts pop up. This is a good time to talk about what's going on. So what we're doing is we are actually downloading these attacks that mimic what an attacker, or we're downloading these scripts that are going to mimic what an attacker is going to do. So by definition, some of these are going to be malicious in nature, right? we've got some of these are going to do what an attacker does, which is malicious. So Windows Defender might not like all of these things. So here we have this virus and threat protection pop up. So there's a couple of things that we can do with this. One thing that you want to make sure is if you are going to install this on a work computer, that you have permission to do so. Even though we know that these are relatively benign things, I mean, I don't think that there's nothing on here that's really going to attack anybody, but you just make sure that you have permission to run it and to install it. That way you don't get in trouble. The other thing that we can do is we can disable Windows Defender, which we need to do in order to run some of these things. And again, you might be saying, well, why do I mean, if Windows Defender catches it, doesn't that mean it's a good thing? Or you might not be using Windows Defender. Maybe it's a different form of antivirus. Isn't that a good thing that my antivirus is catching it? I mean, isn't that the test, is to see if I'm catching it? That is true. It's a good thing that your antivirus is catching it. But you got to remember that attackers can get around antivirus. There's things that they can do that change what an antivirus does. We just had this conversation in work this week. Someone found a way to basically turn off the antivirus, and so there's all kinds of things that can happen. What happens if your antivirus just doesn't start? You still want to be able to detect these types of attacks that come. So disabling your antivirus to run these things, it might seem counterintuitive, but remember that attackers can bypass those things. So if your antivirus catches it, that is awesome. It's great. But can you still detect it even if your antivirus doesn't detect it or doesn't block the use, but doesn't block the running of the attack? Can you still detect that? Just a minute, I'm going to cough. Okay. So again, we're going to disable we can disable Windows Defender a couple of different ways. We can go into the settings and do it. And again, as you're running these labs, you might have to do this multiple times. Mainly because Windows Defender likes to run. So even though you disable it, Windows Defender likes to run. So you might find out that even though you do turn this off, that later you're going to find that it's on. It's a good thing that happens. It's kind of annoying if you want it off, though. So I'm going to turn off these two things. So I guess this cloud delivered protection doesn't matter too much, but I definitely want to turn off the real-time protection. So there's other ways that you can do it. You can turn it off in PowerShell, or you can whitelist these folders. I'm just going to turn it off and we'll call it good at that. Okay, so now that we have it open, now that we have it installed, we can see these folders now. And even if you'll notice, I'm not going back and reinstalling the Atomics folders, even though some of them got deleted. The ones that got deleted are not applicable to our labs, so we don't really need to worry about it. You can see here now that we have this Atomics folder here that wasn't here before, which was confusing me. And so if we open this, maybe, oh man, my computer is dying. Okay, you can see that we have now all of these T folders. And these again are just like what we saw on the website. These go hand in hand with MITRE ATT&CK. We have them now on our computer. If we open it up, let's open up this one. Oh my goodness. Maybe we were looking at 1016, so let's open this up and we can see these files again. We can see the markdown file and the YAML file. Okay, so let's go on now. Now that we have this open, that is the end of lab 2. So the lab 1 was running the atomic test manually. Lab 2 is installing Invoke Atomic Red Team. Okay, so we now are ready to work on lab 3. Let me check the time. Maybe check the time. Okay, so let's go ahead and look at lab 3. So with this open, I am going to do invoke atomic test. And it says, okay, which technique number do you want to run? At this point, I'm not going to run anything. I'll just close out of it. I just wanted you to see that invoke atomic test worked. We can run a test when we do this. What happens if we close this PowerShell and then we open it back up? I am going to invoke atomic test. If I can spell. It isn't there. You might say, well, it should be a capital A. It still isn't there because we need to import that module again. So it's kind of annoying to do that. So there's a thing. What we're going to do is we're going to edit our profile for PowerShell so it does it. So let me show you what import module, and I am going to import invoke, not there, C, atomic red team, invoke. So I'm going to go ahead and import this module. Now that it's imported, now I can invoke the atomic test. So again, if we close the PowerShell, we're going to have to import that module every time. Again, we don't want to do that. So let's go ahead and change our profile for PowerShell. So if I just do Notepad profile, I should see this pop up. I do want to create this file, so yes. So now I've got this cool thing here. In the labs, you can see that there's commands to put in. So I'm going to copy and paste that. That's right in the labs. I'm going to save this and close it. Okay, so now we've already imported this, but I'm going to close it again. And let's see if when I open it, if this time, if it becomes part of PowerShell. So invoke atomic test. There it is. And I didn't have to import it this time because every time I open up PowerShell now, it's going to look at that profile and it's going to run those commands there. And so if there's things that you want to do, you can change the profile to make things a little bit easier for you. Okay, now we know how to import Atomic Red Team, how we can start running a test. So that is the end of Lab 3. So let's go ahead and look at Lab 4. So for Lab 4, what we're going to do is we are going to list the atomic tests that are in a given test. So let's look at the T1003. Let's look at that first. So invoke. And tab complete does work, by the way. So invoke atomic test if you want to do it. So remember before we had this atomic technique, we could put in the T folder here. We can also specify it on the same command, on the same line, which is what I'm going to do basically for the rest of the labs. I'm not just going to invoke atomic test and hit enter. I'm always going to have some kind of commands and flags and things after when I invoke these atomic tests. So what I want to do with this is I'm going to show the details, and I am going to show the details brief, which is different than showing just the details. So I am going to do this basically every time I run a test, because I want to make sure that, one, I'm running the right test, and I want to see which test number to run, which we can see here that now we can see that there's 3 tests associated with this. We can do PowerShell Mimikatz, we can do GSEC dump, or we can do credential dumping with NPP spy. So there's 3 different tests for this technique T1003. So let's say that we just wanted to, instead of show details brief, we weren't sure, and we actually got show details. We can see that they're just, well, I don't know what just happened there. So we can see that a lot of stuff just flew by. We have all of this stuff here, and it's hard to kind of follow what's going on. So let's look at just one of these tests. So instead of seeing all of it, which is a little more than what we want to look at, let's look at, I'm just going to look at test number 1. And the order of these flags doesn't really matter so much. I always put them in the same order, mainly because if I'm going to change the flag at the end, it's easier to modify it there. So you'll see me putting them in this order, mainly because it's easier. I found that it's just easier later on. You can do it in any order you want. So we're just going to look at test number 1. We're going to look at the details for this. Okay, this is much more easily seen here. So we can see that this is OS credential dumping T1003. This first atomic name is Mimikatz, so we're going to dump the credentials for Mimikatz. You'll notice that this information here looks awfully familiar. It's basically everything that's on the markdown file. It's everything in the YAML file. And so we can see all this information right here from PowerShell. We don't necessarily need to go back to the folders. We don't need to go to the web page to look at anything. We can just look right from PowerShell if we remember what the commands are and what we're doing. So let's see. So if we wanted to, we could also call this, instead of test numbers, we can look at test names. Mimicat. So if we want to call it by its name, PowerShell Mimikatz. I'm not sure how critical the capitalization is, but you can see that we can do the same thing with the test names. So you can use test numbers or test names. So there's a lot of information here that we can get. If we want, there's also, you can look at all of the tests. I'm not going to do that because I'm afraid my computer is going to throw up on me. So it's going to dump out a lot of information if you show the brief details. I'm not guaranteeing anything if you do show details on all of the tests. You saw what happened with just one of those T numbers. So you probably don't want to do that with show details on all of the tests, but you can look at the show brief details. It lists out all of the tests. It's kind of a cool thing to do. Okay, so now we have been through lab 4. We know how to invoke a test. We haven't run a test yet. We know how to look at the test names. We know how to look at the test numbers. We can look at the commands, all from PowerShell. So lab number 5 is going to, again, before we even run the test, we want to be able to check to see if we have the information that we need for the test. So remember early on we said that some of these might have prerequisites. So how do we know if there's prerequisites? The attack commands, there's going to be something in the details that says that if there's prerequisites or not. So let's look at one of these tests. So we're going to look at invoke atomic test, and let's look at T1485. And again, I'm going to show details brief just about every time, just so I know which tests I'm looking at. With this one, there just happens to be one. So there's one test with this, so we don't even necessarily need to put a test number in. I'm going to, just because for consistency, just so that we can, so that you can kind of see that what each test needs. Even though if there's only one, you don't need to specify it. If you don't specify a test number, it's going to run all of them. So some of these tests, some of these techniques have 7, 8, 9 tests with them, some of them. So you really want to make sure that you're specifying test numbers. Otherwise, you're going to be running a lot of things that maybe you don't want to run. So test numbers. Oh boy. I really wish my computer was treating me nice. Okay, so test numbers 1. Instead of show details, I'm going to the brief details. I want to look at the full details this time. And it should be plural, show details. Again, we can see that all this information is, boy, I think I found that it's scrolling that it doesn't like. Okay. So we have the attack commands. It's PowerShell, elevation. Do we need admin? Nope, we don't need admin. These are the things that it's going to run, but we have here dependencies. So it says secure delete tool from sysinternals must be on disk at the specified location. We can check to see if there's prerequisites, and there's the command. We can also get the prerequisites by looking at those things there. So let's go ahead and let's just run this and see what happens. I don't think that we've got all the prerequisites, but let's just see what happens when we run this. Well, we get an error. It says that we don't have that file. We don't have sdelete. It said that we needed to have it. We tried to run it without it and we got an error. We shouldn't be surprised by that. So let's see if there's an easy way to check the prerequisites. So you can see here why I have the test numbers before the other flags, because I'm not changing this. Instead of show details, all I have to do is delete that and do check prerequisites. So anyway, I'm again just showing something here. So it says, excuse me, the prerequisites aren't met. We knew that because we got an error saying that it wasn't there. We didn't necessarily need to check the prerequisites, but I was just showing you that you can get that just by check without really getting the error if you don't like errors. Let's get the prerequisites now. So this is downloading the file, it's installing it, and it says the prerequisites are successfully met on that last line. I'm going to go ahead and check them again just because I like to. Now I've got, it looks great. I've got the prerequisites are met. And I'm going to go ahead and run this test now. It looks like it worked. So it deleted that file. And the test was successful. Now, again, what does this mean? And for us, we ran the test. What are we going to do with that information now? Just because we ran it, we can go to our boss and say, yeah, we ran it. Well, no, you need to do something. Are you trying to detect this? Should you try to detect this? Is it important for you to detect it? So these are the questions that you need to be asking yourself when you run these tests. How important is this? Is this something that I need to even worry about? That somebody can securely delete a file and you'll never know that it was there. Maybe that's something that you want to know. Maybe you don't care. So, but you can look at, running these tests, this is something that an attacker would do. If they create a file, they'll delete it so that you won't know they're there. Maybe someone's on the network and they're just creating mischief and they're just deleting everything. So anyway, there's things that can happen with deleting files, obviously, and attackers are going to do it. So are you detecting it? So we have now with this lab, we have run this test. Let's look at another one. Early on, we looked at T1003. T1003, and let's just show details on this before we get too far. Show details brief. There was 3 tests here. We are going to look at the test number 1. Boy. So let's look at the details for test number 1. It says here elevation required is true. So we would expect that if we run this test that it's not going to work, because I don't think that I don't think that I've run atomic or this PowerShell as admin. So let's see if we get an error with this. I don't even, it looks like maybe it worked. So maybe I am admin. Let's try it. Let's check our prerequisites and see. Yeah, so it wasn't successful. But So I guess the error, maybe that isn't the best way to check it. Maybe checking the prerequisites is better. But anyway, you can check the prerequisites. You can try and run it and see if it runs. I will say that even though you're able to run this Mimikatz this way, you're not going to get any password hashes or anything like that unless you're admin. So maybe you are expecting those, the output. It's not going to come unless you're admin. So you would have to go back, restart PowerShell as administrator, and try it again. So you can right click on PowerShell, run as administrator, which we'll need to do in later labs anyway. I'm not going to go through and run this again, but now we can see that we have up here the administrator PowerShell title here. Okay, so now we've got lab number 5 is done. So let's move on to lab number 6, executing. If you look at the labs, this is called Execute Atomic Tests Local, not to be confused with executing atomic tests remotely. You can do it remotely with PowerShell remoting. We're not going to do that in this class. It's hard. We don't need to go into that, but it's hard setting up the environment with which to test that. Let's just leave it at that. Okay. So we're going to go ahead and execute some tests. So let's look at we're going to look at technique T1218. And we're going to look at T1, and there needs to be a space here. And we're going to show details. Like I said, I always do. So we see that there are 4 tests with this. Maybe we want to just we're going to look at 2 tests. We've only looked at one at a time, but maybe we want to do 2. So I'm going to do 2 and 3. And I can show the details with this. And it's going to give the output for 2 tests here now. So if we want to run more than 1 test, we can just put the numbers with spaces in between them. So let's say that I want to actually run these. Let's look at the output for 2 of these. Okay, when we run this, I get a calculator popping up, which is what it's supposed to do. I'm going to close these back down because I don't want to leave them open. It looks like I ran 2 and 3. So what are these? Maybe I should have looked at these details a little bit more. And I'm just going to look at let's look at 2. So what is this? This is executing the technique assigned binary proxy execution. So we're executing command embedded in a DLL or an executable. So again, this is a way that people can get commands to run on your computer without it really looking like their commands are running. I mean, it looks like regserver32.exe was the thing that was run, but we had calc.exe pop up. Now maybe they didn't want to do calc.exe and they've got malware.exe that they're going to pop up as well. Are you going to be able to detect that? maybe you don't. So maybe you don't have anything set up to do that. So you could run this test and check to see if you're finding out if these binaries are getting caught running this way. If we were to do this on something that is not administrator. So remember, I opened up this administrator prompt. Let me minimize that. Oh my goodness. Okay, so let me minimize that. And let's do this again. Invoke atomic tests. Atomic test T, and this is 1218.010, and we did test numbers 2 and 3. So I'm just going to go ahead and run this. I only got one popped up this time. So what was the difference? Well, let's look at, see if we got any error output. It says that elevation was required, but it wasn't provided. So this is why this one worked the first time. Oh wait, that's up there. So it looks like we didn't even get an error when we ran that, but we saw that only one of them executed. So remember, executing it, I guess it might not give you it might not tell you if there's, if the prerequisites are met. So let's go ahead and check the prerequisites. And says that they're met for both. Huh, interesting. Not quite sure what I want. Probably because I've opened up the PowerShell as administrator. So it's seeing that I've got it, even though on this one it's not. I don't know. Might have to look into that a little bit more. Okay. So again, if you go through the labs, you'll see these. You'll get all kinds of calculators popping up. You can close them. And there's all kinds of cool things that that Invoke Atomic Red Team does. Okay. So now we know how to execute these tests. You just leave the test number. We can do multiple at a time. Check the prerequisites first. You can look at the details, all that kind of good information. Now, some of these tests, and we're going to go through this right now with Lab 7, some of these tests have input arguments. So you might have a file that you want to use, or certain information that is specific to your network. Well, you can adjust those things with these input args. So let's look at one of these. So we're going to look at T1016, 1016. And let's show the details brief with this. We can see that there's 4 here. It's interesting. 3 is missing. Let's see if we can figure out why that's the case. So we see that there's 5 tests, 1, 2, 4, 5. Why isn't 3 being loaded? If we go and look at, oh man, I don't know why my computer is being so slow. Okay, so invoke atomic red team, and we are going to look at the atomics folder. And we are going to go to 1016. Maybe. Okay, 1016 gives us the mark. We have 5 tests listed here. Why are only 4 showing up? 3 is missing. Well, let's go and look at this atomic test number 3 specifically. It says here that atomic test number 3, the supported platforms is Mac OS and Linux. Invoke atomic red team is smart enough, so it's not even gonna. It sees that that isn't Windows, so it's not even gonna give you the option to run one of these tests. So it's kind of cool that we don't even see that as an option. Test 3. Can't do it on Windows, so it's not even going to give you the option for it. So that's why when you list some of these tests, you might see numbers missing. So let's look at test number 5. Test number 5. And I just want to show the details. We can see here that we have some interesting red things that we've seen a little bit before. So we can see here that there's variables. So the hashtag squiggly brace, that's the way that you specify variables with invoke atomic red team. And so we can see, again, if we look at the markdown file, we can see if we scroll down to test 5, we can see here that there are 3 variables: the output file, the port file URL, and the port file. So these are the variables that are there. What if we don't want to look at this? We still want to know what the default is. We've got some things here. What can we do with atomic red team to see what those defaults are? Well, we have the command, and then we have the command with our inputs. So this is the generic command. If we scroll down here, with our inputs, this is what is going to run. So this port file and the output file are these 2 things here. So the port file is C atomic red team atomics, this file, and the out file is going to be here. So let's go ahead and run this test. We're going to leave these as it is. And wow, that's new. That's changed since last time. But we can see that there's this file that just opened up or got created here, open ports. So these are the top 128 ports as identified by Nmap that it's checking to see if they're open or closed. And you can see how slow my computer is going, because that should have taken about a tenth of the time. But now we get this file that came out that lists all of the same information. So if we want to have the file documenting what it is, we have that. So now let's say that maybe we don't want to have the same custom input argument. Maybe we want to change this argument. So let's run this test now, except this time we're going to use the prompt for input arguments. So we're going to enter a value or we're going to accept. So this URL to the top 128, I'm going to keep that. I don't want to change that file. I'm okay with the top 128 that's there. So I'm going to hit enter to accept. So this is the output file. So I am going to change this. I don't want to I don't want to have open ports. So I'm going to change that. So I'm going to keep the variables the same. And so I'm going to write this again to the desktop, and I'm just going to call this my egress.text. And I'm going to keep that the same. So this time we should expect a file, and then we can see that it just popped up, called my egress. We've changed that file now from open ports to my egress. And so you can change these variables very easily. So I'm going to go ahead and after this runs, okay, so now we've run this. The lab has some more information on what to go into, but we are quickly running out of time. There's a few other things that I want to make sure that we can get to. But what if we don't want to leave these laying around? Open ports isn't a big deal. Probably you might not care if anybody sees that, but there are some tests that you really don't want to leave the artifacts laying around. So maybe there's a test that's going to dump the password hashes. If you do dump the password hashes, then that's probably not something that you want to leave laying around. And I think that's what we're going to be working on now. So let's look at invoke atomic test T1003, and we're going to look at the sub-technique, the first sub-technique. And let's do show details brief to see what tests there are. Windows credential editor, dump the LSASS. So we are going to look at dumping the LSASS with proc dump. So test number 2. So let's go ahead and look at this. Test number 2, and we're going to show the details. So this dumps the LSASS memory using the proc dump. It says elevation required is true, and there's cleanup commands, there's dependencies that we need to have. So there's all kinds of things that we need to have. One of them, remember, was elevation. So I'm going to change over to this administrative PowerShell window. And I am going to look at this test again, invoke atomic test. T1003.001, test number 2, and I want to check my prerequisites. So it says that the prerequisites have not been met. We need this tool. So let's go ahead and instead of checking the prerequisites, let's get the prerequisites this time. So we've met the elevation privilege because we just changed to the elevation, elevated our privileges. So let's get the prerequisites now to finish the requirements. It is downloading, it is installing. Now we've got this done. Now let's run this test. And let's see what happens. Get rid of the prerequisite flag. Okay. Says the dump one was initiated. We've got this. We've written it. It looks like now we have this lsas dump.dmp file. It's 48 megabytes, written in 3 seconds. So this worked. We can go and we can actually find this file and look at it and see that it's there. Let's see how easy it is for me to do. So let's see if this works. %temp, oh, I need to maybe put in another % at the end. Let's see if that works. Okay, there we go. So the name of the file was lsas dump, Windows temp lsas dump. I'm not in that file. I'm in a different temp file. C, Windows, come on. Temp. Oh man, this is painful. Yeah, give me permission. And we have this file here, lsas dump.dump. Now again, this probably isn't something that you want to leave laying around. Attackers love that file because it has password memory. But we can get rid of any artifact that we leave behind by running the cleanup command. So after we're done with the test, if we know that we've created some kind of an artifact, we can go ahead and run the cleanup command. It's going to go back and basically get rid of everything that we've just done. So let's look and see. That file is now gone. It's no longer there. So the cleanup command makes life very easy to clean up after yourself when you're done with this, because again, you don't want to leave things laying around. Sometimes you'll create a user because attackers like to create users, but you don't want to leave those users laying around if they're not in use and all that kind of good stuff. So cleaning up after yourself is always a good idea. So now that we have run these tests, how can we keep track of what we've done? I hope that this works. So there's something that's called the MITRE ATT&CK navigator. So let's MITRE ATT&CK. I know I've spelled that wrong, but it'll get us there. So I'm just doing a search for MITRE ATT&CK. Boy, maybe I didn't want to spell it wrong. attack.mitre.org. Looks like the right web page. So let's go and look at this. I'm going to click on matrices here. So we can see the attack navigator. We can get to the attack navigator from this page. I'm trying to zoom in on it a little bit. Okay, so let's view the navigator, and we can see this great page that's got a lot of things here for us. Looks like the matrix that we were just looking at. If we click on this, we can see the sub-techniques. So one of the things that we can do with this navigator is we can put layers in. And so these layers really make it handy if we're going to kind of keep track of things. And how you do that is going to be completely up to you, but I'll show you the basics of how to do it. So you're gonna kind of be on your own on how you want to do it, but I'm gonna show you kind of what to look for. So if we go, I should have explained what I was doing here. So I went back to the atomics folder. Remember I said that there's an indexes folder here at the top. I didn't even talk about that earlier, but we're going to look at that now. So we have all of these indexes here that we can look at. So we can look at some of these. Let's look at this markdown index. These are just different ways that we can look at the MITRE ATT&CK and how it relates to Invoke Atomic Red Team. If there's a test, it looks like it's in blue. If there's not a test, it says you can add a test. So contribute a test here if you would like. But these links here will take you to their page. Again, play around with this. Look at some of the things. It's really cool. But we're going to look at this attack navigator layers. So we're in attack navigator, so we're going to be looking at the layers. So hopefully you can see the difference with Linux, Mac OS, and Windows. I'm just going to look at the main layer here, but if you're specifically looking at the Windows attacks, you can just open up that JSON file. So we're going to open this JSON file. What we're really looking for here is the raw data. So I want to look at this raw data here, and I want to get this link from the raw data. What I'm going to do is I am going to create a layer, and with this layer, I'm clicking on, oh boy, that didn't work like I wanted it to. Let's close that. Let's try this again. So we're going to create a layer. So we're going to open an existing layer, but we're going to load it from a URL. So the layer is the JSON data that we just got. And we got this URL from the attack page, from the Atomic Red Team page. And I'm going to create this layer here, and I'm going to paste the URL in, clicking this little alligator symbol at the end, and it's going to create. Now I've got this red thing. So if it's colored in red, then there's an atomic test that's written for it. So this is awesome for me to look at and see which of these techniques have tests written for them. Unfortunately, there still is yet, I'm trying to get changes made on this, but there's still not a way to know. So remember, we had the sub-techniques. If there's a sub-technique, then it's red, but it doesn't show on the technique. So you kind of have to expand all of these things. However, it looks like I don't know if you can see that, but they're in parentheses underneath. It shows, let me zoom in on that. So, for example, this says 13 out of 15. If we click this, 13 out of 15 techniques have atomic tests written for them. So 13 out of the 15 sub-techniques have atomic tests. So even though it's not colored, I really wish that these were colored, but they're not yet. But you can see all of these tests have atomic tests written for them. So there's a lot of tests that have been written, and they're being updated regularly, and it's being expanded on. It's really cool. But anyway, you can see here how Atomic Red Team relates to MITRE ATT&CK, and you can see the overlay, and you can this gives you a visualization of how many tests there are that have been written for all of these techniques. And because I'm zoomed in, it's kind of hard to see. If I wanted to maybe change the view a little bit, maybe it's not going to let me. Nope, don't want to do that. Okay, so this is cancel that. This is again a visualization of how Atomic Red Team relates to the MITRE ATT&CK framework. Now, there's other things that that you can do. This is Lab 9, what we just did. Lab 10 actually goes in how we can put in even another layer and use 2 layers. I don't know if we're going to have time, and I really want to get into the last lab. So after this next lab, if I have time, I'll come back to this and we'll do Lab 10. But again, the instructions on Lab 10 I feel are pretty good. But basically with Lab 10, what you're doing is you're taking some downloadable data that I've given you a link to. So you're going to download that data, and you're going to use it to overlay with other data so that you can get more information out of it. With these 2 labs, hopefully you can look at your own environment, and maybe you can figure out a way in which you can take the results from your tests, and you can overlay them with this MITRE ATT&CK navigator, and you can see visually how you are doing in relation to these techniques that MITRE has for us. So for example, let's say that you ran a test and you detected it. Maybe you want to give that test a score of 1,000. And so that when you see that, it'll show a different color on this. Maybe if you didn't detect it, you'd give it a score of 0. Or maybe you detected a part of the test and you could give it a score of 50. You can come up with your own ways of scoring and all that kind of stuff. Labs 9 and 10 just give you the process of going about how to do that. What you do with that on your own end, that's kind of how it's going to be company specific, right? I mean, every company is going to be different in how you organize yourself. Okay, so lab 11, the last one, it's probably my favorite one. It's writing our own atomic test. So let's go back, and I am going to look at this atomic test T1217, and let's see if I can get back there. Okay. Really unfortunate my computer's being so slow. I apologize for that. Technical difficulties. Okay, so T1217. Let's look at the markdown file. Oh, passed it. I don't know if you can hear my computer beeping when I scroll. Okay, T1217. Don't move. Oh, it moved. I feel like I'm playing whack-a-mole. Okay, got there. Okay, so T1217. I'm going to look at the markdown file. And we can see this is browser bookmark discovery. So there's 6 tests for this. We list Mozilla bookmarks from Linux, Mozilla bookmarks from Mac OS, Google Chrome from Mac OS, and then we have Windows. We have Google Chrome from Windows, Google Chrome and Edge from Windows, and Mozilla from Windows. So there's we have here some tests that we can run to get bookmarks from people's browsers. Is this important for attackers? Sure. I mean, if I know that that your users always go to a certain bank, maybe that'll help me formulate other attacks. Maybe I can do a phishing ruse, or maybe I can set up a fake website with a link that looks really close to it and get them to click on it. Or there's all kinds of things, all kinds of information this has. I don't see here a test for Internet Explorer. Now you might be saying nobody uses Internet Explorer anymore. That might be true. Okay, that might be true. But we're going to go ahead and we're going to write a test in order to get the bookmarks from Internet Explorer. Before we do that, we need to get some bookmarks in Internet Explorer. So I'm going to open up Internet Explorer. Okay, so I've got this opened up. Okay, I've got it opening up. I'm trying to get the bookmarks quickly. I want this link here. Okay. Where's my mouse now? Use recommended settings. Okay. Oh man. I know Edge is better. I'm not going to worry about that. Okay, so now I've got this index here. I'm going to download or maybe I should have stopped and just started my computer again. Okay. No, I'm not going to use Chrome. Okay, I'm trying to open this file. How about I just create my own? I will bookmark this. Okay, I've got now a favorite added. No, I've already got it there. Okay. Okay, so let's go ahead and create this file, this atomic for it. So what I need to do is there's a GUI that's been made to help us create these. So it really is very easy to use and to create our atomic tests. So we're going to start atomic GUI. One of the things that when you do this is the YAML files are very white space specific. So you've got to have the exact white space for it. Sometimes it doesn't work with some browsers, and sometimes it works better with others. So we are going to actually, I think it works good with Firefox. It doesn't work with Edge. So we're actually going to do this in our Internet Explorer. So we've got that open, and we're going to go ahead and it should be opening up. Let's see why this isn't working. It's installing the dashboard. It shouldn't take this long. Okay. I don't know why it just stopped them. That's not a good thing. Okay, so we have this now. Like I said, I'm not going to keep this in Edge. I'm going to open this up in Internet Explorer. So I'm just going to copy and paste that link over there. Now I want to edit our YAML file. So the YAML file, remember, is what tells Invoke Atomic Red Team what to do. So let's go ahead, and this was for the T1217. So we're going to open up this YAML file. So Notepad, C, Atomic Red Team, Atomics, T1217, T1217, and I want the YAML file. So I'm going to go ahead and open this up, and again, the instructions are in the labs for this. But I've got this open up. We can see what we need. I mean, we can kind of see what we're looking for. We could, if we wanted to, copy and paste these. So we can see here we have the name. We're going to list Mozilla Firefox. Now, if I wanted to, I could copy and paste this and just modify it for what I want. That's it's one way to do it. It's not the easiest with this GUI that we have. So this GUI makes things a lot easier. So we can, again, we saw what was required, or kind of what was needed, what we're looking for in our in that YAML file. So we're going to these are the Internet Explorer bookmarks. This is going to, how did they write it here? Searches for, so we are going to get the bookmarks from Internet Explorer. If I was really doing this, I would take more time to make sure that that looks right and everything. But I'm not going to worry about it. Supported platform, we're going to leave that at Windows. So what is the command that we want to do for this? So it says in the lab that we want to do directory /s/b user, oh, I missed that. Users art favorites. Okay, so I'm just going to list out what is in this favorites folder. So that's basically what I'm looking for. So this is run with the command prompt. It doesn't require elevation. We're not going to do any of the other commands that are needed. So we're just going to go ahead and scroll down, and we're not going to put any input arguments. There's no prerequisites, but we're just going to generate this YAML definition. So now, isn't that cool? We have this this YAML file now. Depending on what you're using, you might need to adjust the spacing. Looks like the spacing is right for this. So I'm just going to copy this over here. And I am going to, actually, before I do that, I'll paste it in. Whoa. Maybe. I'll paste it in. Did I do that twice? Yes, I did. I only want one of those. Okay, I just wanted to make sure that I wasn't going to be deleting my whole YAML file. Okay, before I save that, let's look real quick at this test. So invoke atomic test, and we're going to look at 1217 and show details brief. So we knew that there was 3 tests for Windows, right? We looked at the markdown file. We have we have Chrome and Edge, and then Firefox. So what I'm going to do now is I'm going to save this, YAML file. Now let's go back to this, and I'm going to do the show details. And now we have this new one that we just did in test number 7. It automatically puts it on there. It adds it in there. To me, that's just cool. So let's look at test 7 now. Show the details. We see, this is exactly what we told it to do, right? There's even my typo. So let's go ahead and run this now and see what we get. See if my adding that one little bookmark help. Oh, I deleted too many. So there we have our bookmarks, the Art Lab Index, Bing, and links. So we just wrote our own atomic test. I am waiting for someone to submit this to Atomic Red Team, and then I'll have to come up with another one. I hope nobody does. But anyway, this test is creating your own tests. It really isn't that hard. You just have to find the technique and how can you mimic what an attacker would do for that technique. So it might take some research to do, but there's still a lot of techniques out there that need people to write them. We just went through and a very simple Atomic Red Team, or a simple test, and it's pretty easy to do. So we don't have a lot of time left, and I hesitate trying to finish lab 10 in the amount of time that we have. But if you do have questions, I haven't been saying this, but you can ask them in the Discord channel. If you are interested in working on the labs and you didn't get your lab environment, you can ask for one. We're going to leave the lab environments open for about 2 hours, give or take, after the class is over, and then we're going to shut them down. But again, if you have questions, let us know. We are happy to help in any way. So let's go back, and I think we can finish up these slides we went through. I think we went through them all. Thank you for coming. If you want to stay in touch, you can connect with us on Twitter or on the Slack channel. Again, sorry about the technical problems, but hopefully this class was beneficial for you, and we will hopefully see you in another class. We are expanding the class. We're going to make it a 2-day class. So if you're interested in doing more of this type of activity, we're going to be looking at some other things associated with, or very similar to Atomic Red Team, and kind of how you can detect more things and what you can do with it. So look for future classes that you can go to. So anyway, thanks for coming. Have a great day.